Hi all, I'm Deepa, Assistant Professor, Department of Physics from E-Content Development Center, Majlis Arts and Science College, Valancheri. In this session, we are going to discuss about conservation of energy of a particle. Hope you all know about energy, right? Then, what is energy? Energy of a body can be defined as its capacity for doing a work, and it can measure as the work done by the body. For a particle, there are two states, that is state of rest and state of motion. The energy possessed by a body by virtue of its motion is known as kinetic energy. For example, a car that is moving along a road possesses kinetic energy. Its expression is K equal to half mv square. Here m is the mass of the body and v is the velocity of the body. The energy possessed by a body by virtue of its position is known as potential energy. For example, a car parked at the top of a hill possesses potential energy. Its expression is U equal to mgh. Here m is the mass of the body, g is acceleration due to gravity, and h is height of position of the body from the ground. The sum of kinetic energy and potential energy is known as total mechanical energy. Here we are going to study about the conservative nature of this total mechanical energy. For that, consider 2 points in a conservative force field, that is P1 and P2. Let a particle move from P1 to P2. As the particle moves, its potential energy decreases and kinetic energy increases. We can measure the change in potential energy and change in kinetic energy between the 2 points. From the measurement, it is clear that change in kinetic energy is equal and opposite to change in potential energy. The change in kinetic energy can be expressed as K2 minus K1 and change in potential energy can be expressed as U2 minus U1. So, the above statement can be write as K2 minus K1 is equal to minus of U2 minus U1. On RHS, take the negative sign inside. Then the expression will become K2 minus K1 is equal to U1 minus U2. On rearranging this expression, we get K1 plus U1 equal to K2 plus U2. Here, K1 plus U1 is the initial total mechanical energy of the particle and K2 plus U2 is the final total mechanical energy of the particle. That is, initial total mechanical energy is equal to final total mechanical energy. Here, K plus E is equal to the total mechanical energy. From this, it is clear that the sum of kinetic energy and potential energy remains constant in a conservative force field. This is the law of conservation of mechanical energy. The sum of kinetic energy and potential energy can also be termed as energy function E. The energy function E is invariant with respect to change in time, that is d by dt of k plus u equal to 0. To illustrate this, consider a particle of mass m falling freely in a gravitational field from a height x. The equation of motion is given by F is equal to minus mg. Here, the negative sign indicates the downward motion of the particle. We know that F is equal to ma, that is the general expression for equation of motion. Then this expression can write as m is equal to minus mg. Here a is acceleration, okay. Acceleration is the rate of change of velocity with time, that is dv by dt. So, we can substitute it in this place. Then we get m into dv by dt equal to minus mg. On rearranging this expression, we get m into dv by dt plus mg equal to 0. Now multiply throughout by dx by dt, that is m into dv by dt into dx by dt plus mg into dx by dt. Here dx by dt is velocity v. Now we substitute v only in the first term, that is mv into dv by dt plus mg into dx by dt is equal to 0. Here the first term is equivalent to d by dt of half m v square and the second term is equivalent to d by dt of mgx. Now we have to take d by dt outside as common to both the terms. Then we get d by dt of half mv square plus mgx equal to 0. Here half mv square is kinetic energy k and mgx is potential energy u. Then we can write d by dt of k plus u equal to 0. If d by dt of k plus u equal to 0, we can say that k plus u must be a constant. From this, it is clear that the energy function is invariant with respect to change in time, that is d by dt of k plus u equal to 0. In this session, we discussed about the mechanical energy and conservative nature of this mechanical energy of a particle. Here, I am concluding my session. Hope you all understood and thank you so much for watching this session.